Hello everybody and welcome to another mystery box function challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. It's the last week of this year-long series, so every day is a challenge day, and so this math will be particularly challenging today. You can use the link in the description if you want to try this out on your own, and when you've got an idea, come on back and see if we get the same thing. All right, I'm going to start with 0. Okay, so 0 gives us that infinity error, so maybe this is another rational function. Let's make a note of that. And let's try a 1. One gives us 2. How about a 2? 2.5. 3. 3 and a third. This is looking familiar. How about a 4? And that's 4 and a fourth. So we actually saw this same exact pattern yesterday where we were taking the number and then adding 1 over the number to it. So that seems to be happening here. Let's look a little closer to 0, which I think is going to be our asymptote. So let's look at 1/2. And maybe 1/4. Yeah, so far this is actually identical to yesterday. And what we had yesterday was 1 over x plus x. And there was another way to write that, but it'd be funny if we're actually doing a repeat. Let's try in the negatives now. About a -1. So that's different. That is not following that pattern. Okay. That's 1.5. And that's 2 1/3. Let's do one more. And that's 3.75. Oh, I think I have an idea. Let's try -1/2. So this is a pretty odd looking rational function. We've got something very familiar on the right here, one of these slant asymptote ones where the numerator has a higher power than the denominator. This very typical looking curve for that. But then what's on the left has nothing to do with that, it seems. And let's see, what would be the easiest way to approach this? This, just to remind you of this pattern we had yesterday, it was the number plus the fraction. So we were getting, at 1, we were getting 1 plus 1 over 1. At 2, we were getting 2 plus 1 over 2 for 2.5, and that continued on. Here, at 1, we're getting 0. So if we started, so if we had these two pieces still there, we'd have to subtract. Oh, well, it's a -1. Sorry, -1, we're getting 0. So, and let's look at -2 as well. I'm thinking I have a hunch about what's going on here. When the left and the right halves of the graph look sharply different, sometimes there's an absolute value involved. And I think that's what's going on here. Let me think about this. So, positive 1.5. So what if, so we've got a 1 here. No, it was a -1 and a -2 to start with. Let's take the absolute value of that. That makes those positive. And then we're going to add the fraction, right? So 1 over -1 and 1 over -2. So it's a little complicated looking, but this is going to be a positive 1, and then plus a -1 or -1, that's going to be 0. This is going to be a positive 2, and then -1/2, that's going to be 1, 1 1/2. And that is what we're getting there. Let's see if we can predict a value if this is our pattern. So our pattern is, let's try -5. We're going to take the absolute value, and then we're going to add 1 over that number. So the absolute value of -5 is 5, and then we're going to subtract 1/5. So this should be 4.8. So let's put in a 5 and see if, or -5, and see if we get a 4.8. And there it is. Well, I think we've got this one. How do we want to write that? So 1 over x plus the absolute value of x, maybe? Yeah, we'll call that, I don't know that there's any other way to write that really. Well, I guess you could switch the order around. Let's go ahead and reveal. Yeah, they wrote 1 over x plus the absolute value of x, and let's graph that. Yeah, you can see a typical looking arm of a rational function over here, and then a very different one over on the left. Well, how did that go for you? I think that was super tricky. Let me know. Thanks, everybody.